Hello everyone, I'm Q and welcome back to another video for the series. And today I brought a problem from IMO Shortlist from year 2020. So it wasn't an official IMO problem, but it was a shortlist proposed by a mathematician in Israel. So today I would like to share my solution and the official solution. So my solution is, like always, I assume that the minimum will occur when they are all equal to each other. So A equals B equals C equals C because they're all homogeneous. But actually, this case, it doesn't work. And I'll explain why it doesn't work. So this is the case that I was thinking. And when this is true, then let's just assume that they're all equal to A. Then we have 2A times 2A equals A plus A squared. So we have 4A squared equals 2A squared. Therefore, A equals 0. However, it doesn't work because we have A in the denominator right here. So it doesn't work. Now, then the second thing that I was thinking was when A, B, C, D, and are equal to each other, and D and A are closely related to each other. So let's write it. A plus D equals A squared plus AD. We have A squared plus AD equals 0. Now, if this is true, then we're looking for the minimum value of this. However, notice that the minimum will occur when A equals D according to AMG inequality. However, that's not the case because we already proved that it doesn't work when these four variables are equal to each other. So we need to find A and D that are closely related to each other, and our solution is when A equals 0 or A equals negative D. But either case doesn't work because A and D are positive integers, positive real numbers, and A cannot be equal to 0. So scratch that, and we have A equals B and C equals D, or A equals C and B equals C. And the last case is when they're all different from each other, and closely related to each other. But I think this is the last hope that we have, so let's try from our thing here first. So we have A plus C square equals AC plus AC. So we have A squared plus C squared equals 0, but this doesn't work obviously because A equals C equals 0, and that's not what we want here. And let's use this one. Then we have A squared, 2A times 2C 2B equals A squared plus B squared. So we have 4AB equals A squared plus B squared. Now, if this is true, then then we're looking for the minimum value of A over B plus B over A plus A over B plus B over A, which is 2 times A over B plus B over A. Now we just need to find the value of A over B, and that's quite simple. We can just do this. Because we know that A is a positive number, we can divide A on both sides by A on both sides. So we have x squared, let x equals B over A. So we have x squared plus minus 4x plus 1 equals 0. So x is 2 plus or minus root 3. Now here we have two cases. So first of all, let's consider this case. The second case is this one, but we don't know which one will be greater because this one and this one, we know that this one is bigger, but this one and this one, we know that this one, this one is bigger, so it might somehow cancel things out and we don't know. So we actually do need to check that. And they turn out to be equal to each other. So we have 4. So both of them are 4, so this thing should be 4, and we have 8 here. So our minimum is assumed to be 8. And that turned out to be an correct answer, and yeah, that was my solution. However, I think I will not get like full credit for this solution because I didn't quite elaborate the case when A, B, C, and D are all different from each other, because that somehow might, it's very unlikely, but it may lead to a solution, a smaller value. But yeah, so I think I might get some points off from there, but at least that was my attempt. And I will share the official solution. For the official solution, there were 3 solutions and I love them, but I especially love the first one because it used like the most basic inequality, aka AMGM inequality. I'm not saying that it's the most basic, but like it's like, I mean, I think you get it. It's like most commonly used inequality. So we first need to rearrange these 2 terms, like switch, and then we know that this is greater than or equal to. Use AMGM for these 2 and these 2, so we have AC over BD plus 2 times square root of BD over. Why is my, because my pad was tilted. Now this is equal to 2 times root A, B, C, D, and it magically leads to AC plus BD, and this is equal to 2A plus C times B plus D over root A, B, C, D. And now we're going to do one more clever thing, is using AMGM here. So we have this is greater than or equal to 2 times 2 root AC times 2 root BD over root A, B, C, D, and because they're all positive real numbers, they cancel out. This is greater than or equal to 8, always. Therefore, our answer is 8, and yeah, that was our answer. And I think this is much cleaner, and because the reason why this is true is because AMGM inequality is true for all real number. I mean, all positive real numbers, and I think I don't quite remember like the exact name of the theorem, but I think there was a theorem or lemma that says that for every AMGM inequality there always exists the equality conditions, so our answer should be 8. And our equality will be resulted when A equals C and B equals D, and yeah, so that was this problem. I think the kick here was like rearranging the terms using AMGM, and like it's quite obvious here, but using AMGM again. I don't know why I'm keep approaching these kind of problems like in this method, but I think I really should change it. So yeah, thank you so much for watching this video. I hope you enjoyed it, and tomorrow I'll come back with another fun problem. Thank you and see you tomorrow. Bye.